What is the minimum possible speed of a rotor ride if the coefficient of static friction between your back and the carpeted walls of the ride is 0.87? The radius of the cylinder is 3.4 meters. The first thing you want to do is draw out a diagram of the scenario. So if you don't know what a rotor ride is, like me when I first read the problem, it's basically a circle and it's an amusement park ride, and the passengers sit with their backs up against the walls, and then the cylinder of the ride starts spinning extremely fast, and as a result, the people's feet basically lift off the ground and they're stuck to the walls as the circle is spinning. So here I drew out the top view of the ride. So you have the circle, and then on the edge of the circle, against the wall, is your person with his back against the wall. The acceleration is pointed towards the middle of the circle. That's your centripetal acceleration. The radius of the circle, as we're told in the problem, is 3.4 meters. Then you have your velocity, which is the direction that the person's going at a given point. And since this is not moving up or down, you know that there's no acceleration on the y, so I wrote down here that there's zero acceleration on the y-axis, and we're looking for the minimum velocity. So now we draw out our free body diagram, which in this case you want to look at the system of the person. So the person has gravity acting upon it. It has static friction, which is keeping the person on the wall and not falling down. So that's going to be pointed upward. And then you have, on the x-axis, you have the normal force of the wall acting on the person, which in this case is going to act as your centripetal force. So first off, we're going to look at our Newton's second law equation for the y-axis. And it's going to become the force of friction minus the force of gravity is equal to 0. So after you can manipulate that, you find out that the force of friction is equal to the force of gravity. So the force of friction is 9.8 times the mass, which is an unknown value. Then we're going to come over to the left and we're going to look at the centripetal force equation, which is centripetal force equals mass times velocity squared divided by the radius. The mass is still an unknown value. Velocity we don't know, that's what we're looking for. Radius we could plug into 3.4 meters, which is given to us in the problem. And like we said earlier, we know that the centripetal force is actually the normal force. So we're going to put in normal force for centripetal force. So now you have an equation for normal force and you have an equation for the frictional force. So now we can look at the coefficient of friction equation, which has the force of friction equal to the coefficient of friction times the normal force, or in this case, the centripetal force. So you substitute your values from the other equations, and you find that 9.8 times the mass equals 0.87 times mass times velocity squared over the radius of 3.4. The masses are both unknown values, and those are going to eventually cancel out, so you don't need to worry about the mass. So then you're left with 9.8 equals 0.87 times velocity squared divided by 3.4. We can then divide 9.8 by the fraction of 0.87 divided by 3.4 and find that the velocity squared equals 38.3. Then you square both sides and find that the velocity, the minimum velocity, is going to be 6.2 meters per second.